Hello guys, welcome back to another video in the LLMs related playlist. So in this video, we are going to see about Codellama. So what is the agenda of this video? What are all we'll be seeing in this video? In this video, we'll be going through this blog of Hugging Face, which is about Codellama, Llama to learns to code. Okay, so these are the guys who have done it, and we'll go through this completely, in which they have said what is Codellama, what are the um, parameters which is available, and they have also given a testing playground. Okay, and once this blog is done, we'll also be seeing about how to fine tune Codellama and how to infer it in Google Colab itself. Previously, we have done a lot of projects using Llama, but we weren't able to save it, right? So save it and infer it. That was not possible. But finally, in this video, I'll also show you how to save and infer the model. Followed by that, as a bonus, in this video, I'll also show you how to infer Codellama in your CPU itself in local. This is an application which is running in local. That is the agenda of this video, guys. So before moving into this video, just let me take 2 minutes to show this website. I'll make a detailed video on this website for sure very soon. But I just wanted to let you know that there is this website called NHP Docs, which I have created recently. So as the name suggests, it is a documentation site for our YouTube channel. Okay, so whatever video I post, all the description of the video along with the links and the resources will be available. So this is the homepage which will have the playlist and their links. So let's say if I'm interested in LLMs related playlist, you can go to this playlist page. So here we have LLMs related playlist. The playlist link is there, and here are the videos available. And when this video is uploaded, you will see a Codellama link also here. So here is the description for each video. But the good part is here I've embedded the video, as well as if you want, if I have used some notebooks, the notebook is also available here, from which you can just copy and then paste and then use it. So that is the document, guys. So if you are thinking, okay, I just need everything in a single place about this channel, this is your place where I will have anything and everything related to our channel being updated here. And as a bonus, if you are wondering how to build such a website, here is the source code. So it is open only. So here's the source code. You can just take this and then you can work on it. Okay, so that is about the website. And more importantly, you have a search bar here. Let's say if I'm talking about LoRa, we have LoRa playlist here. I've created a chatbot that is there. We have for cricket news to match report. There also we have used LoRa. So whatever we have used LoRa, wherever we have used LoRa, it will be there. Okay. So yeah, guys, if you are interested, check this website out. It will be very useful for you while you are going through the videos in this channel. I'll have this link in the description and you can check it out. Now, let's go on with this blog. So if you see, Codellama is a state-of-the-art coding model, which is an open access version of Llama 2, which was recently released by Meta. And the Codellama is the same license as like the Llama 2, which is permissive community license, which is available for commercial use with some restrictions. Okay, so now coming on to this Codellama. What is this Codellama? Codellama, if you see, it is a family of model which in which there are three variants. They are 7, 13, and 34 billion variants. And the more important part you should note is they have took a base model, which is Llama 2, and then they have made two pipelines out of it. One is a Python specialist model where it was just trained for Python alone, and then another one is instruction tuned. Okay, so we had three models, which is Codellama Python, Instruct, and Codellama, which is the base variant. Okay, and here if you see, they have trained it for 500 billion tokens of data, and when you are coming into Python specialist, they have additionally trained it for another 100 billion tokens. Okay, so but the good thing here is Llama 2's base context window was 4K, and for Codellama it was 16K. Okay, and it is said that you can extrapolate it up to 100K tokens. So if you can have input length up to 100, input length or output length both are same here, right? When you're having causal LM, you'll just complete the sentences. So you can generate up to 100K tokens. That is what it means. And this was possible due to a recent paper called ROPE, okay, rotary position embedding. Um, there was this paper called rotary position embedding scaling. So I'll also paste it here. So here it is there, right? Extending context size via rope scaling. So this is an interesting paper. So if you want a detailed video on this, just let me know. I'll make a video on that also very soon. Okay, and we have seen about this pipeline. In all the variants, there are 7 billion, 13 billion, and 34 billion. Now coming on to how to use this Codellama. So if you want to use this Codellama, you can use it via Transformers 4.33 version. So which means you need the latest version of Transformers, and we'll see about that while we are fine tuning it in Google Colab. So that is there. But before moving into that, here they have given a Llama playground, Codellama playground, which is running Codellama 13 billion at the backend. So instead of this example, let me run another example. Here it is saying remove non as key. We'll just run it. Okay. So here if you see, it will remove all the non-ASCII characters from the given input. Okay. So it is working good. That is fine. And under this playground, they are using text generation inference, which I've made a video on detailedly to say how to deploy your LLM in local as a chatbot itself by using chat UI. Okay. So that is there. Now they have also given some sample code for inferencing it for different types of tasks. That too in the free tier of Colab itself, which we will be using. So we can do code completion, we can do code infilling, and if you see like for those the prompt also will differ. Okay, for code completion it doesn't matter, you can just leave it as it is. And if you are going into code infilling, you can just leave it as fill me. Okay, and in case of if you see conversational instruction, which is just talking like a chatbot, you need to give an instruction followed by system prompt and closing the system prompt. Finally, you should have this message and close your instruction. Okay, this is kind of the template which has been followed here, and this is how you can create it. The prompt, first the starting token is there, then you have the system prompt with the system prefix before that, because these work with the custom prefix. Okay, then we are closing the system prompt and we are giving the user prompt. So this is how we should provide the input. Okay, and if you are going for some conversations, you can follow this. And if you are saying, okay, I'm not able to fine tune it with normal Llama 2, you can just load it in 4-bit, which is QLoRA, and yeah, then also we can fine tune it. So here are some performances by, let's see, if about 7 billion. We are having a Python. For Python, it has code 29.298 and JavaScript 31.8. Average leaderboard score is 24.36. All right. So that has been better than Star Coder even. So average leaderboard score is 24.36 for 7 billion, but Star Coder 15 billion has scored only 22.74. Okay, that is cool. So that is about the introduction to Codellama, guys. So yep. Now here it is coming IDFX. So if you're wondering, IDFX is the largest open multi-model model right now available, and I've made a video on that also, which is in our channel. You can just check it out, as well as fine-tuning Llama 2 with DPU, that is also available. You can just check it out. Instead of Llama 2, I've used Santa Coder, but if you have some good GPUs, then you can also do Llama 2 by just changing the name. Now let's move on to fine-tuning, guys. So here we have this Google Colab notebook. first we are installing the libraries which is required as usual: accelerate, pef, bits and bytes, transformers, trl. Those libraries are being installed and we are logging in to the notebook. Okay, so these are all some conventional ones which we have done already. And here if you see, we are just following the same input format they have said. Like, when we are giving an instruction, we'll give the instruction here along with the doc string, and we'll close the instruction. So before moving on to that, we'll see the data set. Okay, let me go into Hugging Face. Here we'll paste the data set. Yeah, we have the data set here. There are 252k rows it seems, and we'll be focusing on code and doc string. Okay, so here it is, code, and we have the doc string here. And if you're thinking, okay, I'm not gonna write in some instruction way, then what you can do is still you can just use this original string directly. Okay, so it will just work as a code completer. That is also fine, you can still do that, and I recommend you guys to do that. Like, just have data df of text is equal to data df of original string, and run the same code and let me know if the performance is better. Okay, so here we are just loading the validation split because the train is so high and we are not going to train it for longer time. So here we have 10k rows being loaded, and then we are converting it into pandas, and we are formatting the prompt. Once that is done, we are again converting it into Hugging Face dataset. From dataset to pandas, then prompting it, and then followed by that we are creating the dataset again. Next, what we are doing is we are creating the tokenizer. Sorry guys. Here we have the tokenizer. Codellama 7bhf is what we are using, the base variant, and we are stating that the pad token is the UOS token. Okay, so as usually we are loading the model in 4-bit, which is QLoRA, obviously. So here we have the model checkpoint. Quantization config is that we are loading it in 4-bit. The quantization type is normal float precision 4. The computation D type is float 16, or even we usually sometimes specify it as torch.float 16, and double quant is true, and device map is auto. Okay, so that is there. Model.config.use catch is equal to false, so that we'll say that okay, we are fine tuning it, we are not just inferencing it. And pre-training TP is equal to 1 is set to replicate the performance of the pre-trained model. Okay, and here we have the peft config. So nothing very new here. R is equal to 8, LoRa is alpha is equal to 16, 0.05, bias is equal to none, task type is causal LM. And why I've left here is I want you guys to try different variants of LoRa config, guys. By like this, have target modules is equal to give some variants. Okay, I want you guys to try something like this. Okay, I'm just removing it right now, but I want you guys to try different target modules combination. We have seen different combinations right now, right? QKV, QV, and then QKV along with linear layers, linear layer alone. I want you guys to try different variants and let me know which gave the best performance. And whoever does the one best, maybe I'll give a shout out, and that would be great, right? So that is about LoRa config, but yeah, still it will work to some extent without this target modules alone. Without target modules itself, it will work to some extent, but it is very necessary to specify it. But I want you guys to try it. Okay. Next, we have this training arguments. Nothing very unusual here. We are training it for 100 steps max. Say strategy CPOC, and Elastic data type is cosine. We have learning rate is equal to 2e minus 4 as specified in Llama 2 paper itself. Gradient accumulation steps is 4. Batch size is 8. Nothing is very new here, guys. And we are also pushing it to hub. Okay. We are using the SFT trainer. If you remember it, we have used this for Llama 2 fine tuning. We have used it in DPO. We have used it in a lot of videos. So if you want a detailed explanation on these, check the DPO video. Okay. DPO implementation, to be very specific. So we are providing the model, we are providing the data, we are providing the pef config, we are providing the field text input field, which is text here, right? So we are providing that. We are providing the training arguments, tokenizer, packing equal to false, which will slightly slow down the training, but it's fine. Like that wouldn't be a problem with 100 steps, obviously. And I've set a sequence length of 512. So once that is done, we are training the model and then we are pushing it to the hub. Okay, so that is about the code for fine-tuning Llama v2 for Codellama. Okay, so because this use Llama v2 as its base, like specified in this blog itself, which we saw sometime before, right? So yep, once we are training it, it will take some time, guys. And finally, after 100 steps, it reached 0.90 loss, which is fine for a quantized model. Okay, what I done was, for a safety, I copied it into the drive. So what I recommend is, before running this notebook, just have a drive mounted here, then you can execute this directly easily. Okay, next is this interesting part which we haven't done yet in our videos on related to Llama. We have done this for Santa Coder, but it didn't work for Llama, but now it will work. Okay, so what we'll do is, we'll first create the Llama model itself. We'll make an instance out of it. But here what we'll do is, though the torch D type is float 16, we'll not load it in quantized manner. It will be in default. Okay, it will not be in 8-bit, it will not be in 4-bit, it will be normal 32-bit, if I'm not wrong. Okay, and device map is auto, that is as usual. So by that we will have the model. Next, what we'll do is, I've already pushed this adapter model to hub, right? So we'll just call that here. I'm just pasting it here. So here you can see fine-tune codex is there, in which I have adapter model and adapter config, right? We'll be calling those in this PEF model. What it will do is, it will take this adapter model which is available in this hub, and it will combine that with this model. So basically we'll just do the process of replicating this same model. Here it would have generated inside, okay, PEF config. Once it was training, it would have run the same code, and we are doing the same. Okay, and what we are doing is, obviously we are merging and unloading it, which will merge these layers to its base layers, and that will be fine, right? Like when you're merge and unloading it, you're going back to your own original model. What is the good part in that? I'll show you while we are inferencing it. Guys, the problem is, the model is pretty huge. So what is the main issue is that you can't save it. Okay, you can't run the save pretrain function here because it exceeded the RAM. So what you can do is, you can directly push it to the hub. Okay, when you have such an option, you can just do that. Push it to the hub, and before that, don't forget to have the login, because what you need to do is, once you have trained the model, restart the runtime, again do the installation and login to the notebook. Okay, then start running these. So once that is done, when you are uploading it, maybe you can use the same repository or different repository as per your choice. So here I gave a different repository. I'll just copy this and paste it here. So here we have this pin, right? Here you won't be able to find adapter. See here, we have the PyTorch model directly, which you can use for inferencing by using the pipeline function itself. Because if you had this PEFT model function, right, then you need to write your own inference function. That is also fine, but it is more easier when you use pipeline function for rapid inferencing, right? So that is it. So first you can push the model, then you can push the tokenizer. Then what I done was, now the model is trained, it is saved, the adapter model is saved in your drive as well as in hub. We have merged it with the base model, and we have uploaded that as well in the hub. Now what we are doing is, we are gonna inference it. Okay, so we are using the same one which we uploaded in the hub. The same repository is used here to create a pipeline which will have a D type of float 16 and device map is auto. That is fine. So in this pipeline, what I expected for the model is to generate a function of Fibonacci, and here are some parameters, toppy, which is 0.9, and then temperature parameter is there. You can play with these parameters if you want. And finally, once these outputs are there, we'll print this out. Okay, so here you can see result is def Fibonacci of n. If n is equal to 0, return 0. L if n is equal to 1, return 1. L if n is equal else Fibonacci of n minus 1 plus Fibonacci of n minus 2. It is following the recursion approach, and that is great. And also, if you see, it is getting the input and it didn't run the Fibonacci of n, that is fine. But because I have restricted it to 100 tokens, possibly the 100 tokens would have ended by now, but maybe you can also try it with some increased number of tokens. Okay, so isn't that amazing, guys? You can just fine tune it and infer it and save it everything in Google Colab itself. So yeah, that is there in this video. But like I said previously, it is not all we will do in this video. We are going to see how to infer it in the local itself. Okay, but you may think, Vasant, I don't have GPUs. I don't have like good GPUs. Maybe I don't have RTX 40, 60, 40, 70. Guys, even I don't have that good GPUs. I do have a GPU, but the size is very less. I have an RTX 3070 Ti, but it is around 6 gigs if I'm not wrong, and it is not enough for loading these kind of models. So what I did was I inferred it in CPU. Yeah, you heard it correctly. This application which you are seeing now, this Gradio application, in which I inferred the Llama model, where I asked it to generate even numbers from 0 to n given numbers, where it amazingly generated, guys, def even numbers of n for I in range of 0, n plus 1. If I% 2 equal to 0, I will be returned. That is the exact result I was expecting from this model, and it done that. But guys, just remember one thing, it will take some time to do some inferencing. So that is there. So you need to be having time to do that inferencing. Okay, so even if I run now, it will take a lot of time. Now for the coding part. Before moving into that, I would like to show you the model which we use here. Okay, so let me go into Hugging Face. Okay, now it is getting right. I'm just stopping it, guys. The system is slightly getting overloaded for me. I'm also closing the server. If you see, the server is closing, right? But you can run it. I've shown that you can run it, right? It will take some time, but it will run. Okay. Coming on to how to use this model. This is the person called the book. Okay. He's the user in Hugging Face, where he usually uploads models quantized. Okay. There are different formats. There is GGL, GGUF, and recently there is this version, this is this format called GGUF. Okay, so I'm just opening another one and I will show you. Okay, so GGUF, if you see, it is a new format Llama CPP team. If you wonder Llama CPP team, who are those? These are the guys who started supporting Llama in C++ inferencing in the local CPU itself. Okay, so they have said that okay, we are not supporting GGML anymore, and we are moving to GGUF, which is a new format. Okay, it is as similar as GPTQ and GGML. Okay, so here what we are using is we are using this model. Okay, I'm just gonna copy this. Maybe let me paste it here. I don't know if it will come. Yes, it won't come. So here it is. Codellama 7b instruct GGUF. This is what we are expecting here. And if you see in files and version, there are different types of quantization, out of which I chose this Codellama 7b instruct Q4 quantization method KM. Okay, Q4 KM. I chose this, but you can try with different methods as well. You can just download it first into the local. So here, if you see, I have it in my local. Okay, I'm just showing it now. So here you can see I'm having it my local, and as you see, the server is closed, which means the application will be down right now. But I've shown you already, right? You can fine tune it and infer it. What is the point is that while you are doing this inference, right, you are not using the model which we fine tuned right now. So this is a model which the bloke guy quantized it. Okay, so if we can quantize it to that same format he said, then we also can do this. But for now, we are using the Codellama 7b instruct, which was used in default. Okay, for this, what are all is needed? The prerequisite is that you need to have Gradio and C transformers library. So if you're wondering what is C transformers, let me show you in a minute. Okay, so let me show you their GitHub. C transformers. So here you can see these are the models supported right now: Replit, Dolly, V2, Starcoder, StarChat, MPT models, Llama, Falcon, GPT, NeoX, StableLM, GPT-2, GPT-J, GPT-4, all J. Okay, and you can also use this with Hugging Face Hub and LangChain also. Okay, so guys, I'm planning for a playlist by using LangChain. There are some projects which has been interesting for me. Okay, so I'm planning to make a playlist on that. We'll update you all soon on this. Okay, so this is the library which we are going to use, and it is just the Python bindings for the transformer models which are implemented in C++ by using ggml library, but now it is changed to GGUF. Okay, so that is about C transformers. If you are interested, you can just go through this. I'll also have this link in the description. Okay, now let's move on to our code. Okay, so here is our code. What I'm doing is here we are loading the model Codellama 7b instruct Q4 KM GGUF. Just give me a minute, guys. So as you can see, guys, we are loading the model here. Okay, the model type is Llama, and we are allowing 64 tokens. Okay, but you can increase it as much as you want. And there is this another model function called chat with model, which will take the input chat, which is our input, and the chat history, which is the prior input chats which is available. So okay, so when we are loading, first we are loading the model, and then we are asking the model response for the given input chat. So it is a simple code, guys. We are just giving some 3 examples, but you can type your own examples here. And we are calling the chat interface from Gradio's library. Gradio is an amazing library which will help you to make some rapid inferencing UI. So in that, what is the function which we are having? We are having chat with model, and the title is Codellama 7b GGUF demo. That is what is there, was there, right? Like the title of the site. And we are also providing the examples. Okay, so we are finally doing launch, which will launch the application basically. And if you set server is equal to true, you can share it to your friends as well. Okay, so that is about this video, guys, where we have seen about how to fine tune Codellama. What is Codellama? Basically, what are all the advantages in that? We have seen that it is providing the state of that performance. And finally, as a bonus, we have also seen how to infer it, right? So here you can see there is this image. This is what we finally done. So yeah, guys, if you all like this video, please hit the like button. It will show that you all like this kind of contents. And let me know if you want any more videos by your side, by in the comment section, because I take comments very important, because that is the one place where you can share your opinions to me. And previously some persons have asked me about inferencing of Llama, and here we are. We have seen how to infer it in Google Colab. We have seen how to infer it in CPU in local. So yeah, You can ask your questions in the comment section, and I'll still make videos or respond to it as much as possible very soon. Okay, and share it with your friends and community to the max, so people might get some useful information from this video. So yeah, don't forget to hit the like button. Okay, so I hope you all like the video. Thanks for liking the video. I'll see you all in the next video, guys, which will be mostly about evaluation of LLM. Until then, cheers.